Hello friends, in this video we will discuss about nucleation and growth. This topic is very important for PG students and for those who are appearing for any competitive examination like NET, SET, etc. In this video we will cover the following topics. What is nucleation? Then we will discuss about types of nucleation. Then we will see what is the difference between homogeneous and heterogeneous nucleation. Then we will discuss about the particle growth as well as crystal growth, and we will see what is the basic difference between particle growth and nucleation. Now, how we define nucleation? Nucleation is the initial process of the formation of a crystal. The crystals may form from solutions like liquids or from vapor. Here, a small number of ions, atoms, and molecules get arranged in different patterns, forming a site where additional ions and molecules can get attached with in order to make the crystal larger. For example, nucleation occurs when sugar is supersaturated in water, allowing sugar molecules to stick together and form large crystal structures. Now let's see the types of nucleation. Nucleation are generally classified into two categories, primary and secondary nucleation. Primary nucleation again classified into homogeneous and heterogeneous nucleation. Now let's see how we define primary and secondary nucleation. In a supersaturated solution, new crystals can be formed in the absence of crystalline solids of the same substances, which is termed as primary nucleation, or in the presence of crystalline solids of the same substances, which is termed as secondary nucleation. Now, the primary nucleation also classified into two categories, homogeneous nucleation and heterogeneous nucleation. Now, how we define homogeneous nucleation and heterogeneous nucleation? Homogeneous and heterogeneous nucleation are the two major forms of nucleation. The difference between homogeneous and heterogeneous nucleation is that the homogeneous nucleation occurs away from the surface of the system, whereas heterogeneous nucleation occurs at the surface of the system. So these are the basic difference between the homogeneous nucleation and heterogeneous nucleation. They also differ from each other according to the location where the nucleus forms. A nucleation site is a liquid-vapor interface at which a nucleus forms. Therefore, suspension particles, bubbles, or the surface of a system can act as a nucleation site. The heterogeneous nucleation occurs at nucleation site, or we can say that the homogeneous nucleation occurs away from the nucleation site. Now let's see the basic difference between homogeneous nucleation and heterogeneous nucleation. If we define the homogeneous nucleation, so homogeneous nucleation is the process of nucleation that takes place away from the surface of the system, whereas the heterogeneous nucleation is the process of nucleation that takes place at the surface of the system. If we talk about homogeneous nucleation on the basis of nucleation sites, so homogeneous nucleation does not involve any nucleation site, whereas heterogeneous nucleation involves nucleation site. The nucleation goes at the nucleation site. If we talk about the speed of homogeneous nucleation, so the speed of homogeneous nucleation is slow, while the speed of heterogeneous nucleation is fast. The nature of homogeneous nucleation is less common. If we talk about heterogeneous nucleation, so the nature of heterogeneous nucleation is most common as compared to homogeneous nucleation. Now, the homogeneous nucleation on the basis of free energy barrier is high, and the free energy barrier for heterogeneous nucleation is low. If we talk about the homogeneous nucleation on the basis of surface area. So the surface area that contributes to the growth of the nucleus is high, and for heterogeneous nucleation, the surface area that contributes to the growth of the nucleus is low. Now the summary of homogeneous and heterogeneous nucleation are: homogeneous and heterogeneous nucleation are the two major forms of nucleation. The difference between homogeneous and heterogeneous nucleation is that homogeneous nucleation occurs away from the surface of the system, whereas heterogeneous nucleation occurs at the surface of the system. So these are the basic difference between homogeneous and heterogeneous nucleation. Now, how we define particle growth? Particle growth is also known as crystal growth, and it is a process of increasing the size of a pre-existing crystal structure. It has three stages: nucleation, coalescent, coagulation, and agglomeration. Here, nucleation initiates the process, and then additional ions and molecules bind with the newly formed crystal structure to grow it larger. Moreover, crystal growth occurs in all the three dimensions, and this figure represents the crystal growth in three stages. Furthermore, if the molecules or ions fall into different positions rather than the real position in the repeating pattern of the growing crystal, then crystal defect may form. Usually, these molecule or ion trap inside the crystal in a fixed position. Therefore, crystal growth is irreversible. Now, let's see what is the difference between nucleation and particle growth. As we already discussed that nucleation is the initial process of the formation of a crystal, while particle growth or crystal growth is the process of increasing the size of the pre-existing crystal structure. So this is the key difference between nucleation and particle growth. Moreover, while nucleation is an initiation process, particle growth is the provocation of this initiated process. Examples for nucleation and particle growth include homogeneous nucleation of diamond in the gas phase and the formation of sugar crystals when sugar is supersaturated in water respectively. Now let's see the more difference between nucleation versus particle growth. So nucleation is the initial process of the formation of a crystal, while the particle growth or the crystal growth is the process of increasing the size of a pre-existing crystal structure. Atoms, ions or molecules combine with each other in nucleation to form initial site for the formation of a crystal. While in particle growth, additional atoms, ions or molecule attach to the initial site of the crystal formation. Example of nucleation is homogeneous nucleation of diamond in the gas phase, and for particle growth, the formation of sugar crystal when sugar is supersaturated in water. Now the summary of nucleation versus particle growth is: in brief, nucleation is the first step of particle growth, and the key difference between nucleation and the particle growth is that nucleation is the formation of a new structure, whereas particle growth or crystal growth, it is the process of pre-existing structure becoming large. So this is about